Right, this recording is to help you with lesson 5.05, multiple angle and product of sums formulas. Again, we're going to be using mostly formulas presented in the online lesson, so make sure you get those down in your notebook somewhere. They're also on the sheet that I handed out a couple weeks ago in class with that trig identity tables on there. Okay, so the first one we're looking at, we want to find cosecant of 2 theta. We don't know how to do the 2 theta, so let's see if we can rewrite that. Well, cosecant is the same as 1 over sine of 2 theta. And we do have a formula for sine of 2 theta now. We can rewrite it as 2 sine theta cosine theta. And then we'll have to use our triangle that's given to us to find what sine theta and cosine theta actually are. Alright, well, looking at this right triangle, I know the hypotenuse is 5. It's a Pythagorean triple, your very standard one of 3, 4, 5. You can also use the Pythagorean theorem if you're unsure of that third length there. Okay? So then sine is 3 over 5, cosine is 4 over 5, and tangent is 3 over 4, using that triangle there. Alright, we only need sine and cosine in this one. So sine is 3/5 and cosine is 4/5. So let's multiply those numbers on the denominator together. When we do that, we get 24 over 25. So really we have 1 over 24 over 25. Remember, you cannot divide fractions, so to change this to a multiplication problem, you need to multiply the top by the reciprocal of the denominator, and that simply gives you the 25 over 24 for your final answer. Okay, for the next one, let's try to solve for x if possible. Well, we don't have a sine x, cosine x, but I can actually rewrite the 4 sine x, cosine x using a double angle formula, and that can be rewritten as 2 sine 2x. Okay, so using that formula, we can rewrite the left-hand side. And now I'm going to work backwards to try to solve for x. Okay, so I divide each side by 2 and get sine of 2x equals 1/2. Now remember, we pretend the x isn't there. So where does sine equal 1/2 on our unit circle? It equals 1/2 at pi over 6. And I'm going to add in a 2n pi here. And it equals 1/2 at 5 pi over 6. Alright, I'm going to divide everything by 2 so that I can have just x equals. So if I divide everything by 2, I get 12 in my denominator of my first fraction. And it's just n pi at the end. Okay. Same thing in my second one here, divide everything by 2. That becomes 12 in the denominator, and 2n pi divided by 2 is just n pi. Alright, I am going to put a common denominator here of 12, only because when I start entering values in for n, it's easier on myself. So when I start putting values in for n, I start with 0. So I'll get pi over 12 in the first equation, and 5 pi over 12 in the second equation. Okay, neither of those are greater than 2 pi. So let's move on to n equaling 1. So 12 pi plus 1 pi is 13 pi over 12. 5 pi plus 1 pi is 6 pi. Oopsie, I forgot my 12. No wonder that wasn't making sense. 12 plus 5 is 17. Much better. So I actually get 17 pi over 12. Neither of those are greater than 2 pi, so I'm going to move on. N equals 2. 24 plus 1 is 25 pi. And uh-oh, that's too big. Anything greater than 24 is too big. So we stop there. We don't have to go any further because everything else will be greater than that. And we end up with those 4 answers. All right, next, let's find the exact values of sine 2u, cosine 2u, and tangent 2u. So again, these are all just using your double angle formulas. The only thing you'll need to do is set up a right triangle to find the missing information. So notice that you are dealing in the first quadrant, so everything is positive. Okay, so it's a 3, 4, 5 triangle. So if sine is 3 over 5, so it's opposite over hypotenuse, cosine would be 4 over 5, and tangent would be 3 over 4. So all you need to do is just plug these values into your equations and then multiply to get your fractions. Notice that in cosine and tangent you do have squared values. Just remember to square your fractions. So cosine squared is 4 squared over 5 squared, so that's 16 over 25. Sine squared is 9 over 25, and tangent squared is 9 over 16. So don't forget, if it does have a squared value, you need to square that fraction as well. All right, when using the half angle formulas, these are a little bit more tricky, but when we're thinking of it, and I can write 112 degrees 30 minutes as a fraction. There are 60 minutes in an hour, so I can do it as 30 over 60. Change that to a decimal and get 112.5. Now because I'm using the half angle formula, I need to find what the full angle would be. So if we double that, we get the 225. So really you're looking at sine of 1/2 times 225 there, and cosine of 1/2 times 225, and tangent of 1/2 times 225. So really all you're doing is plugging information into the formulas and then using your unit circle where needed. So we do not want to leave things in terms of cosine 225. We're going to change that to square root 2 over 2 instead. Same thing here. Change it to square root 2 over 2. And same thing down here. And then simplify. Okay, the next one here, again, very similar, only we're using the half angle formulas this time. We need to find the missing information. We are dealing with quadrant 2 this time. So this tells me quadrant 2. So setting up my right angle, I know my missing side is negative 12. So I get sine being 5 over 13. Cosine is negative 12 over 13. And if you were to need it, tangent would be 5 over negative 12, but it's actually not needed in the half angle formulas. Only sine and cosine are used. Okay? So again, here is just mainly substituting values in and then simplifying. And that's all. The last one is just verifying algebraically, and it's basically just rewriting your problem. I can take the left-hand side, and since those are double angles, I can use cosine of 2 times 2a. And all I have to do is multiply 2 times 2 together to get 4. And I think that's actually an alpha, not an A, because that's a Greek letter there. So 2 steps and you're there.